In this video, we're going to go over some trig word problems that are a little bit more difficult. So we're going to keep a couple of things in mind whenever we're approaching trig word problems. We're going to think about what kind of triangle our diagram has to be in order to use trig ratios, and that would be a right triangle. So if you don't have a right triangle, you can't use trig ratios. We're going to label the sides of our triangle with opposite, adjacent, and hypotenuse from the focus angle. And we're going to think about, are we solving for a missing side or a missing angle? Then we can think about which trig ratio applies using SOHCAHTOA. We can think about if we're going to pick sine, cosine, or tangent. And then if we're solving for a side, we're going to cross multiply to solve. If we're solving for an angle, we're going to use inverse trig. Pause the video so you can check out each question. So we're going to do the question on the top first, the one that says Diego needs to install a support beam. So please pause the video, think about it, try it yourself, and then unpause the video to see the solution. Our focus angle here can be the 38-degree angle. It could be any angle in your right triangle other than the right angle. And from there, I'm going to label opposite, which is across from that angle, adjacent, and hypotenuse. And remember, the hypotenuse is across from the 90-degree angle. We are solving for a side here. Since we are finding the hypotenuse and we have information about the opposite sides, we're going to be using O and H, so we're going to use sine. Sine of the 38-degree angle is equal to opposite, which is 24.5 or 24.5, over hypotenuse, which is x. From here, since we're solving for a side, we can put this over 1 to make a proportion and cross multiply. We have x sine of 38 is equal to 24.5. Then we can divide both sides by sine of 38. And if we put this into our calculator, we can see what x is approximately. And the question does say to round to the nearest inch, so we're going to make sure to do that. And that's approximately 40 inches. Pause the video for the next one. Read the question, try it yourself, and then unpause the video when you're ready to see the solution. Once again, we have a right triangle, and from our focus angle, I can label opposite, adjacent, and hypotenuse. We're solving for a side again, and this time we do have information about opposite and hypotenuse again. So if I write down SOHCAHTOA, we're once again going to be using sine because that has the O and the H. So sine of the 86.3-degree angle is equal to opposite, which is 183.27, over hypotenuse, which is x. Since we're solving for a side, we can make a proportion, and we can cross multiply. And then from here, we can divide both sides by sine of 86.3. And that is going to be the side that we're finding. It does say to round to the nearest hundredth of a foot. So that is 2 decimal places when we enter this into our calculator. So let's do that now. $183.27 over sine of, let me remind myself what that was, 86.3. And to 2 decimal places, that's 183.68. For the next one, please pause the video, think about it, and then unpause the video when you are ready to see the solution. We're finding x, but remember we have to use right triangles. So we can't set up a trig ratio with this triangle, even though that triangle has x as a side, because it's not a right triangle. So instead, we have to use the right triangles in the diagram. We have the big right triangle. And on the big right triangle, if we find this, that can help us get closer to x. And we also have a small right triangle. And we can use the small right triangle to find this side. And then we can subtract the two, and we can end up with x. Let me just call them names other than x, because x is what we're finding. So I'll call this side y, and I'll call this side z. It doesn't really matter. So we're solving for sides, and what I need to do is label the triangles from my focus angle. So let's start with the big blue triangle. The focus angle is 38.8. We're finding opposite, and we have information about adjacent. This side's the hypotenuse, but we don't know anything about it, so I'm just going to leave it off so we don't get confused there. And for the focus angle in the small triangle, which is a 30-degree angle, we're once again finding opposite. And this side is also adjacent for the small green right triangle. So we're using opposite and adjacent for both of the triangles. And that means we're going to be using tangent with O and A. So let's start with the blue right triangle. So I'm going to call that the big right triangle. So tangent, and the angle in the big triangle is 38.8 degrees, is equal to opposite, which is y, over adjacent, which is 440. Since we're solving for a side, we can cross multiply. We have 440 tangent 38.8 equals to y. Next, we'll set up our tangent ratio for the small right triangle. And in the small right triangle, we have tangent of the 30-degree angle is equal to opposite, which we labeled as z, over adjacent, which is once again 440. We can put this over 1, and we can cross multiply. 440 tangent 30 equals to z. And now we said in order to get x, which is what we're actually solving for in the diagram over here, all we need to do is y minus z. So I'm going to do that in my calculator. I'm going to subtract the two values we found, and I'm going to make sure to round to the nearest foot, which means the nearest whole number. So 440 tangent 38.8 minus 440 tangent 30. And that's approximately 100 feet. Moving along. Please try the next one yourself, and when you're ready, unpause the video. When it's talking about angle of elevation, the angle of elevation is when you're, for example, standing on the ground and you're looking at something that's taller than you, that's higher up. And it's the angle at which you're looking up at something that we call the angle of elevation. The nice thing about the angle of elevation is that it's always inside the right triangle, to the left of the right angle on the bottom, so it's always in the same spot. We can also have something, it's not in this question, but it's going to come up in a later question, called the angle of depression, which is if you're up higher, for example, if I'm this bird looking down at the person, and I'm looking down, It's the angle at which I'm looking down at. That would be the angle of depression. And the angle of depression is always in the same spot as well, outside the triangle. But outside the triangle doesn't really help you if you're trying to use trig, because you need a focus angle inside the triangle. So the next part is that the angle of depression and the angle of elevation are alternate interior angles, so they're congruent to each other. So if you were given the angle of depression, you would still know the angle of elevation and be able to solve the problem. We're finding the angle of elevation. So that's our focus angle. I'm just going to label it as theta, an angle that we don't know that we're trying to figure out. And from angle theta, this would be opposite, and this would be hypotenuse. The other side would be adjacent, but we don't have any information about it. So that tells me we're going to be using sine, O, and H. So sine of the angle that we're looking for is equal to opposite over hypotenuse. And since we are solving for an angle, we're not going to cross multiply. We're going to use inverse sine of the ratio, and that's going to give us the angle that we need. It does say it's round to the nearest tenth of a degree, so that means 1 decimal place. So let's put this into our calculator. Inverse sine, 5 over 25. Second sine, 5 over 25. And to the nearest tenth, that's 11.5. I almost rounded it to 2 decimal places. .5 degrees. Sorry if that's a little messy over here. Let me fix that. Okay. Please pause the video and unpause it when you are ready to see the solution to this question. So we are finding the angle of elevation of the roof frame. So what we need first is to split this into right triangles. And since it's symmetric, we can split this into 2 right triangles. Our angle of elevation would be this angle right over here. The angle that if you're at the bottom of the roof and you're looking up at the top of the roof, that you would be looking up at. And that's what we're finding. Since it's symmetric on both sides, this side is 12 as well as this side. So from our focus angle, we can label our triangle. We have opposite, which we don't know anything about and we're not finding. We have adjacent, which we do have information about. And we have, oh, my bad. We have opposite because it says that the frame rises 4 feet above a house. So that is the height of the roof. So we do have the opposite and we do have the adjacent is 12. The hypotenuse is the one that we don't know anything about here. So if I write SOHCAHTOA down on my paper, I'm looking for opposite and adjacent, so that's tangent. So tangent of the angle that we're looking for, the angle of elevation, is opposite, which is 4, over adjacent, which is 12. Since we're solving for an angle, we can use inverse tangent to get the angle that made that ratio. And it says to the nearest degree, so the nearest whole number. So inverse tangent, 4 over 12. Oops, my calculator has an add. Okay, and to the nearest degree, that's about 18 degrees. Okay, pause the video and unpause it when you are ready to see the solution. We're finding the measurement of angle BST, which is located inside this purple triangle because angle BST is this angle. The problem is we can't use trig on that purple triangle because it's not a right triangle. So unfortunately, we can't directly use trig on it. So we're going to have to look for the right triangles in the diagram. And we do have just like a previous example that we saw, we have a big right triangle in blue. And we also have, let's use the same color we used before for the small one. We have the green right triangle as the small right triangle over here. So let's think about what's going to be helpful for us in determining angle BST. In the big triangle, we can find this whole big angle, which is getting us closer to angle BST. In the small green triangle, we can find this angle, which is also getting us closer to angle BST, because if we subtract the blue minus the green angles, then we get this purple angle, which is exactly what we're looking for. So let's call the big blue angle X, and let's call the green angle Y, and let's solve for it. So, and when we subtract, we'll have the angle that we're looking for. So let's label our triangles from our focus angles. So for the big triangle, from the angle that we're finding, which we labeled as X, we don't know anything about opposite, but we do have adjacent and we do have the hypotenuse. So adjacent and hypotenuse we're going to be interested in. And in the small right triangle from angle Y, once again, we don't know anything about opposite. It's the same opposite. It's the same adjacent, so we do have that information. And we do have the information about the hypotenuse of this green triangle as well. So for both of them, we're going to be interested in adjacent and hypotenuse. And that is cosine. So let's start with the big right triangle first. So we have cosine of angle X, we don't know the angle, we're looking for it, is equal to adjacent over hypotenuse. And since we're solving for an angle, we're going to use inverse cosine of the ratio, and that is the angle that we're looking for. In the small right triangle, we're going to set up our cosine ratio. Cosine of angle Y, we're looking for that, is adjacent 917. Oh, I almost made a mistake there. In the blue triangle, the hypotenuse is 1,425. In the small green triangle, the hypotenuse is 1,048. We can use inverse cosine in order to find what y is. So now that we have what x and what y is, we can subtract them in our calculator, and then we can get angle BST, and it does say in the question to round to the nearest degree. Inverse cosine 917 over, let me not forget it, 1425. Oops. Okay, and then the second one is inverse cosine. And that was 917 over 1048. And that's approximately 21 degrees for angle BST. For the next one, please pause the video and unpause it when you are ready to see the solution. In the first part of the question, we are finding the distance from the base of the tree, so that means the bottom of the tree, to the point where the longer cable is attached to the ground. So we're finding this side of the right triangle over here. What we know is the 12 feet, and we know the 50-degree angle. We also know the 3 feet, but the 3 feet is part of the non-right triangle. So my plan is going to be, if I focus on this small right triangle in blue, which is a right triangle, and I find this side, then in order to find the side I actually want, which is in green, I can take the side that I find x and I can add 3 to it. So that's going to be my plan. From the 50-degree angle, the 12 feet is opposite. This is adjacent. This would be hypotenuse, but we don't know anything about the hypotenuse. So I'm interested in opposite and adjacent, which is going to be tangent. So tangent of the 50-degree angle is opposite over adjacent, which is what I'm looking for. I'm going to cross multiply since we're solving for a side. We have x tangent 50 equals to 12, and then divide by tangent 50 on both sides. We have 12 over tangent 50. And it says to round to the nearest foot. So let me do that in my calculator. 12 over tangent 50. And that's about 10 feet. So I'm going to put that here. X is approximate. Oh, oops, I almost made a mistake. That's not my final answer. We have to add 3. And my final answer is about 13 feet. And then we have the whole side that we're looking for. And I'm going to put it in the diagram as well. This whole side is 13 feet. In the second part of the question, we need to find the angle of elevation between the longer cable and the ground. So this cable is the longer cable. Here's the ground. So this is the angle that we're looking for. So that angle is in the larger right triangle that I'm outlining in red. And in that larger right triangle, we have opposite is 12. And we just found the adjacent side to be 13 feet. So opposite and adjacent is once again tangent. So tangent of the angle that we're looking for is opposite over adjacent. And if we take inverse tangent of the ratio, we'll get the angle. And we are rounding to the nearest degree. So inverse tangent, 12 over 13. And that's approximately 43 degrees. Okay, we're going to check out this question next. So please pause the video and unpause when you're ready to go over it. First, I'm going to fill in the missing angles. Angle DCB is 35 degrees. Oops, 35 degrees. And angle ACD is 75 degrees. Just be careful there. 75 plus 35, let's try that out in our calculator. And notice that's not a 90-degree angle, so just be very careful with that. It's not a 90-degree angle. Determine and state the distance across the pond, AB, to the nearest meter. So we are looking for this distance over here. So if we're going to use trig, we do need to look for right triangles. And luckily, we have 2 right triangles in this diagram. Let's take a look at this one first. From this one, we do have our 75-degree focus angle. I'm going to circle it. And this side would be opposite. This side would be adjacent. And this side would be hypotenuse. If we can find the opposite side from here, and then in this triangle, which is also a right triangle, from the 35-degree angle, if we also find the opposite side, then we can simply just add them together and get the length of AB. So that's going to be our plan. So once again, in the blue triangle, we also have adjacent. So we have opposite and adjacent that we're interested in. So that's going to be tangent. So let's start with the pink right triangle. So tangent of the 75-degree angle is opposite. Let's just call this one y, and let's call this one z so we don't get confused, and then y plus z will make x. So equals to y over adjacent is 85. We can put this over 1 and cross multiply. We have 85 tangent of 75 equals to y. And then we can do the blue triangle over here. Tangent of the 35-degree angle equals opposite, which we labeled as z, over adjacent, which is 85. And then from here, we can cross multiply since we're solving for a side. And then all we need to do from here is simply just add those two lengths together to make the full side AB. So on my calculator, I'm going to do 85 tangent 75 plus 85 tangent 35. And to the nearest meter, that would be about 377 meters. For the next example, please pause the video and then unpause when you are ready to go over it. We need to find the distance from the campsite to the tower, so from C to T. That's what we're looking for. But unfortunately, in this triangle, it's not a right triangle, so we can't use trig on it directly. But this triangle is a right triangle. But the issue with this triangle is that we just don't have another side of this triangle to use to make trig. We have an angle, the 55-degree angle, but we don't have a side. The 400 is not from the big purple triangle. The 400 is from the smaller red right triangle. I can highlight that a little bit better. So what we're going to have to do is we're going to have to use the small right triangle to get another side from the big right triangle, so that way we can use trig on the big right triangle. So it doesn't matter what side you find. I'll just label this as y. Let's find this side, and then we can use it in the big right triangle. So I'm going to just write red over here for the small right triangle because it's in red. So from the 72-degree angle, that would be opposite that we're looking for. And we also have adjacent. So if I write down SOHCAHTOA, I'm looking for opposite and adjacent, so that would be tangent. So tangent of the 72-degree angle, that's the one inside the red triangle, is opposite over adjacent. And since I'm solving for a side, I can cross multiply. Y is equal to 400 tangent 72. And I'm just going to leave it like that so I don't round early. Now I'm going to do a trig ratio for the purple right triangle. So from the 55-degree angle, we just found opposite, so we can still use opposite. And we're looking for the hypotenuse. So we're interested in O and H. So that's going to be sine. Sine of the 55-degree angle equals to opposite, which we just found to be 400 tangent 72, over the hypotenuse, which is what we're looking for, x. I'm going to put this over 1 and cross multiply. 400 tangent 72 equals to x sine 55. To get x by itself, we'll just divide both sides by sine of 55. And this will be my final answer when I put it into the calculator, and it does say to round to the nearest foot. (400) tangent 72 over sine of 55. And that's approximately 1,503 feet. Okay, let's check out this next one. Please pause the video and then unpause it when you are ready to go over it. So the angle of elevation of the ramp is 4.76 degrees, so that would be over here, 4.76 degrees. And we need to first find the length of the ramp. The problem is that we don't have any right triangles here, so we're going to have to make one. So since I want to find from here to here, to the top of the ramp, it makes sense to draw my right triangle here, because that way I can just solve for x and x will be the ramp. And I'll have the ramp and I don't have to like add or subtract anything to it. So that's what I'm going to work on. But I need another side. Luckily, I can get this side over here because all of these 6 inches are making up that side. So this would be 18 inches. Problem is, it does say to find your answer to the nearest 1/10 of a foot. So I can't use inches in my trig ratio and expect to get my answer in feet. So what I'm going to do is I'm actually going to convert to feet right now, so I don't have to worry about that at the end. So inches to feet is divide by 12. So I'm going to take 18 and divide by 12. And 1.5, I'm going to just use that value. So I'm going to actually erase this, and I'm just going to replace it with 1.5 feet. And now I can label my triangle. This is opposite from the 4.76 degree angle. This is hypotenuse. So when I write down SOHCAHTOA, I can see I'm using sine. So sine of the 4.76 degree angle equals to opposite, which is 1.5 feet, over hypotenuse, which is x. And since I'm solving for a side, I'm going to cross multiply. We have x sine of 4.76 equals to 1.5 feet. And then to get the x by itself, we can just divide on both sides. And I can put my answer into the calculator, and then I can round to the nearest 1/10, that like the question says, 1/10 of a foot. So 1.5 divided by sine of 4.76. And that's 18.1 approximately feet. So the ramp is 18.1 feet. And the second part of the question is asking us to find the horizontal distance D. So we are looking for D to the nearest foot as well. So what we can do in our right triangle is we could find this side over here, which from the 4.76 degree angle is adjacent. And we have 2 other measurements that we can use. We can either use opposite or hypotenuse because we have both of that information. That means you could also use Pythagorean theorem if you wanted to. And then what we're going to do, because D is not that full side, is we're going to have to subtract this piece off. And that piece is 2 of these 8 inches. So this piece is 16 inches. But remember, we want our answer in feet. So I don't want to use 16. I'm going to divide it by 12 to convert from inches to feet. If I hit math, enter on my calculator, it converts it to a fraction in lowest terms. So that is 4/3 of a foot. So I'm just going to change it, and I'm going to actually just use as my measurement 4/3 of a foot. And now I can set up my trig ratio. So I'm going to use opposite, the 1.5, and we're finding adjacent. So that's going to be tangent for this part. So tangent of the 4.76 degree angle is 1.5 over, I'll just call it y, the whole side that we're finding. Cross multiply because we're solving for a side. And then we're going to just divide on both sides. And I'm going to put this into the calculator. 1.5 divided by tangent of 4.76. And then remember, I had to subtract off the 4/3 of a foot piece. So that way I could get just D, which is approximately 16.7. Okay. For the next one, please pause the video and unpause it when you're ready to go over it. So in this one over here, the first thing that we need to do is find each step rise. Let me just label that each step run is parallel to AB. And let me also put in the 10 for the step run. Each step run has a length of 10. The angles are labeled. What I need to do in order to figure out of each step rise is I need to, inside any of these right triangles that have a step rise, I need to get an angle so that way I can use trig to find the step rise. So I do have this 36-degree angle over here, and luckily it's alternate interior over here. So I'm going to use this 36-degree angle. We do have parallel lines, so we do have congruent alternate interior angles. So from the 36-degree angle, the step rise, which is what we're looking for, is opposite, and we have adjacent. So opposite and adjacent is going to be tangent. So tangent of the 36-degree angle is opposite over adjacent. Since we're solving for a side, I'm going to cross multiply. 10 tangent of 36 equals to x. And it does say to round to the nearest tenth, so I'm going to just put this into my calculator. And that's 7.3 approximately inches. So each step rise is approximately 7.3 inches is what we just found. For the second part, we do need to find the length of AC. So in order to find the length of AC, we need the side because 3 of those make up AC. You can use Pythagorean theorem because now you have 2 sides, but I'm just going to use trig again. So this time we're looking for hypotenuse, and I'll just use adjacent because we were given it, and hypotenuse. You could also use opposite because you just found it. So adjacent and hypotenuse, I'm going to use cosine. I'll just call it y, what we're solving for. Cross multiply. Okay, and then to get the y by itself, we're going to just divide by cosine of 36 on both sides. Let me put that into my calculator. Oops. Uh-oh, another add. Okay. What was I typing in again? 10 over cosine 36. And that's about 12.4. But remember, we need 3 of those to make AC. So I'm going to go back to my calculator and just multiply that by 3. And that's 37.1 approximately. So I'm going to put that here. AC is approximately 37.1 inches. One more question for this video, because this video is getting really over time right now. So we're going to do one more question for this video. So please pause the video and then unpause it when you're ready to see the solution. Here we have angle of depression. So I'm going to use the fact that angle of depression and angle of elevation are alternate interior to get angles inside the triangles. So I'm going to start with the 36-degree angle. That is alternate. Let me use a different color. If I look for my letter Z, that's alternate interior with this angle over here, which is 36 degrees. And now 25 degrees. If I look for my letter Z, is alternate interior with this angle over here. So now we have angles inside the big and the small right triangle. We have the small right triangle over here in green. And we have the large right triangle over here in red. So all I'm going to do is set up a trig ratio using both of those triangles. I'm going to find the side from the big triangle. I'm going to call it x. I'm going to find the side from the small triangle. I'm going to call it y. And then I'm going to subtract the two. I'm going to do this super quickly because we've done a bunch like these now. The only difference here was using the angle of depression to find the congruent angle of elevation. So I'm going to start with the big red triangle. So I'm looking for adjacent, and I have the hypotenuse. So that's going to be cosine. Cross multiply super quickly. That worked out nicely. I didn't have to divide anything. For the green triangle, we're once again finding adjacent. And we're once again have hypotenuse, so cosine. We're solving for a side, so let's cross multiply. And now I'm just going to subtract the two in my calculator, x minus y, and round to the nearest foot. And then the other one was 774 cosine of 36. And that's approximately 349 feet.